Hi, my name is Richard, and I'll show you how to perform a forensic incident investigation on an Oracle database using information recorded by Core Audit. To try this yourself, go to bluecoreresearch.com, click on the online demo, and launch the Core Audit console. We will perform the investigation in the Data View panel. To be able to read the text, make sure you're watching this video in HD and maximize the player to full screen. The events we will analyze are from the Core Audit Table Security Report. This report shows new SQL constructs accessing sensitive tables. Let's look at the Lenox 32 repository. The first SQL that was flagged by Core Audit is this update to the salaries table. As you can see, it was run using the application account. Going back to the Data View panel, let's select the Lenox 32 database. And then we'll try and find that update. The reason we can't see the update is that it was not typed into the database, it was executed inside PL SQL. So let's uncheck the client SQL only and try again. If we now filter, we will see that this SQL happened twice, once from HR app and once from sys. Both are suspicious and are in the report, but let's start with HR app. You can also see that the SQL itself has 9s in it. This is because the security repository we're looking at right now removes numbers and strings. The downsides of the security repository is that the time resolution is 5 minutes, and the SQLs are missing literals. The upside is that this repository records everything that happened regardless of policies. Now let's go into the compliance repository and see if this SQL was recorded by one of the policies we had. The compliance repository has exact transcripts, but since these take more disk space, you have to set up rules that define which SQLs to record. Let's search for this update, and then we'll remove the depth 0 filter since we know that this SQL was running inside PL SQL. As you can see, both SQLs were recorded. The reason is that one of the policies we had deployed recorded every access to the sensitive tables. Right now, we want to look at the SQL from HR app. This SQL Plus session was started by user BlueCore at 6:43 and 23 seconds from a computer called BlueCore2 with this IP address. The SQL itself ran at 6:43 and 23 seconds. Now let's click on the session to see the transcript. Again, let's remove the client-only filter to see inside PL SQL. As you can see, this update ran as depth 1 from this PL SQL block that was at depth 0. This block obfuscated a SQL to hide its intent. It did a translate and then an execute immediate, but Core Audit caught it and alerted on it. This update doubled the salary for employee number 3. But let's find out what values it had before and after. So let's go to the Data Changes view. This view is collected from the Oracle redo logs using the log miner collector. So let's search for Operation Update, User HR App, and Table Salaries. Unfortunately, the application did a lot of updates to the salaries table. So let's go back to the By SQL view. We'll see that the serial number on the session was 165. Let's quick search for 165. And this update happened at 6:43 and 23 seconds. It changed the salary from about $233,000 to $467,000. We even have an undo SQL that will change that row back to its original value. As you saw, this is a SQL that was obfuscated inside the application account. Core Audit was able to capture it, alert about it. In our investigation, we found the session, the SQL, the causes for the SQL, and the data values before and after the execution. That was interesting, but let's find something a little more challenging. Let's go back to the report. If we look at the Solaris Repository, that's where the credit card application was running. Tom is our DBA, and he did a lot of bad things here. He tried to steal the credit cards using materialized views, triggers, and synonyms. He also tried to use Toad to select and do updates. But for all these, we don't even need an investigation since we can see it in the report. I am curious about this insert. It clearly made a copy of the cards table, but let's find out how. Let's go back to the data view and search the compliance repository for this insert. Again, we see the session started at 7:31 and 1 second. It executed the SQL 2 seconds later. And we see session start, user, the program, machine, the OS user, and IP. Clicking on the session ID to see the full transcript, and we already have the client SQL only checkbox unchecked. Let's search for our SQL. And we'll highlight it, and then remove the search, and then find the SQL. So it looks like this insert ran at depth 1 inside this delete. But why would Oracle copy the credit cards table when you delete this My Copy table? If we check the client only checkbox again, we'll see that the DBA created a trigger that copies the credit card table whenever he deletes this table. Later, he selected the My Copy table to get the credit card information. In order to avoid detection, Tom tried to use a trigger to hide his malicious copy. However, not only did we see the trigger creation in the report, but also the insert the trigger executed inside the delete statement. As you can see, Core Audit is a very powerful tool for detecting security breaches and for analyzing them later to find out exactly who did what, when, and how. Thank you for watching this video. For more information, please contact us at info@bluecoreresearch.com.